Let's look at some exponential growth and decay applications. We're going to start with exponential growth functions and decay functions. So our formulas are for the growth function, we're going to have f of t, means our function over time is equal to a times 1 plus r raised to the power of t, where a is my initial amount, r is my rate of increase, and t is the time. If I go ahead and get the formula for the decay function, the decay function will be f of t, my function over time, is equal to a times 1 minus r raised to the t power. If you notice, the growth is positive and the decay, my rate, is negative. So same meanings. A is the initial amount. My R is the rate of decrease. And then my T is my time. The only thing that we do have to remember here is that you gotta have the same unit of measurement. Gotta have your same units of measurements for both the increase and decrease. So looking at number 1, it says Brooke started her career with an initial salary of $32,000. So annual salary of $32,000. But that's our starting amount. Each year she received a 2.5% raise, so that's my rate of increase. If Brooke plans to retire in 30 years, there's my time, what will her yearly salary be when she retires? So plug everything into my function. I got my function over, and actually I can do, it's not f of t, but it's my function for time of 30 years is equal to my initial amount, which is $32,000, times 1 plus my rate of increase is 2.5%. I need it as a decimal. So 0.025, and then raised to my time, which is my 30 years. Now, you can put this whole string in your calculator just like that. Make sure it looks just like that. And you should get my function for 30 years should be, we're talking about annual salary. So that's dollar amount. So you know you're going to round it to the nearest hundredths place. And we should get $67,122.16. There's my answer. That will be her annual salary in 30 years when she plans to retire. Number 2, in 1995, a magazine had 14,000 subscribers. 14,000 is what they started with. If the number of subscribers increased by 40%, that's my rate of increase. Each year thereafter, how many subscribers did the magazine have in 2016? My screen is shaking, and I have no clue why. Okay, so plug everything into my function. So my function over some time, because I'm not sure about the time, is equal to my starting amount, 14,000, times 1, I'm increasing, plus 0.4, because that's 40% as a decimal, over my time. It said in 1995, so that's when it started. And then how many are they going to have? It increased every year thereafter. How many will they have in 2016? So I need to figure out how many years there were between 1995 and 2016. Subtract that, and you're going to get 21 years. So my time would be 21. Again, go ahead, put that string in here. That's F of 21. So my function, after 21 years, they should have 1,639,8,978. So they'll have 16,398,978 subscribers. So that is people. There's your answer. Okay, number 3. Kate drank an energy beverage with 150 milligrams of caffeine. That's the starting amount. The amount of caffeine in her system decreases approximately 12% per hour. How much caffeine is in her system after 8 hours? So my function over 8 hours is equal to, I'm decreasing, so I got to use my decay function. My starting amount is 150 milligrams times 1 minus my rate as a decimal is 0.12 raised to 8 hours. So put that whole function in your calculator, and you should get F of 8 is equal to 53.95 milligrams. There's your answer. Okay, now we did exponential growth, exponential decay. Let's look at continuous growth. So sometimes it's not growing incrementally, it's actually continuously growing. It's a whole different formula for that. So our formula for continuous growth, our amount is equal to P times E to the RT, where A is your amount, P is your initial amount or starting amount. So this is my initial amount. E is your irrational number E. R is my rate. You have to make it positive if it's increasing and negative if you're decreasing. And then T is your time. Okay, so 4, garbage dumpster started with 4 pounds of garbage. So there's my initial amount. The amount of garbage increased continuously. So I know I have to use the continuous growth function by 35%. A day from this point, each day from this point forward. Find the amount of garbage in the dumpster after 2 weeks. Each day, okay. So 1 here, I gotta pay attention to my units of measurement. It's increasing each day, but they're asking how much garbage in the dumpster after 2 weeks. So 2 weeks is gonna give me 14 days. Since it's increasing continuously by the day, I need the days in my function. So plug everything in. The amount should equal P, which is my initial amount, 4, times E, irrational number. My rate is 35%, and I'm increasing, so it's a positive 0.35 times my 14 days. Put this whole string in your calculator, and for your amount, you should get 537.16 pounds. There's your answer. And the last one, population of a town is declining at a continuous rate, so of 1.5%. It's declining at a continuous rate of 1.5%. If the current population is 16,000 people, there's my starting amount. Let's do blue. Find the population in 8 years. There's my time. Plug everything into my function. The amount is equal to, I started with 16,000 people times e to the rate. I'm declining at 1.5%, so it's going to be negative because I'm declining. 0.015 times my 8 years. Put that whole string in your calculator, and for your amount, you should get 14,190. And again, we're talking about population, so that's people. I can't have a percent of a percent. Okay, go ahead and watch the second video that has to do with compounding interest. Thank you. I am. It's still recording, Mr. Stein.